Hey, good morning, everybody. All right, Mr. Sean here from YATJA. Welcome back to our YouTube live stream. All right, now what we're going to be kicking off today with, we're going to be applying all what we have learned with applying to CXC past papers, right? So, welcome. Let me know where you're joining from. Also, please don't be afraid to send messages, all of those things if you don't understand something. Yeah, don't forget to like, don't forget to subscribe. Let us, appreciate any support there. All right. Now, how we're gonna get started today is let's see what I have on the agenda. Give me 1 second. Let me see what I want to pull up for you guys. Yeah. Let me do two things. This client wants me to. All right. Sorry. It's a. Give me 1 second. And we get started. All right. Boom, boom. All right, there we go. Sorry about that. Just wanted to make sure that everything looks how I want it to look. All right. Okay, let's gonna switch over there. Boom, boom. All right. Now, what we have here now is some snippets from CXC exam questions, right? Now, what we want to do here is first make sure we understand what we're reading. Yeah. So a big part of the math is that we have to make sure we can understand it. If we read it and we understand it, then we can at least have a fair try at it. Yeah. We're gonna start with B. We're not gonna start with A now. We're gonna start with B today. All right. Because I want to first start off with how to create expressions. So we have the creation part here, and then we're going to evaluate it after. Yeah, so those are the concepts that are kind of being relayed in these two questions, right? It says write the following phrases as algebraic expressions, right? 7 times the sum of x and y. Now, a couple keywords here. I see the word sum. What does sum mean? What does sum mean? Yeah, it's the same thing like if you see total. If it's the same thing like you see, combine. What does that mean? That means I'm bringing two things together. So that means that if I'm summing up x and y, that means I'm adding x to y. Now, in previous live streams, you've seen that x can't add with y, no. So this is the furthest I can go with it, right? Now, then it said 7 times that. So 7 times what I get when I add x plus y. So then I'm going to say, well, I got to first do x plus y. Then I have to multiply it by 7. Now, if you're used to me putting 7 times, no worries, right? But remember here, for algebra, we're not going to explicitly write in the multiply sign, you know. You're going to notice that when you see me clamp it together, mean I put the 7 right outside the bracket, the 7 is multiplying with the bracket. Yeah? So this is what they're looking for as the result there. Alright? Hopefully that makes sense. Alright, let's go to number 2. Keywords. Do you see any keywords here? I see the keyword product. And I see the keyword consecutive. Now, let's take it one by one. What does product mean? So just like how we know sum is a trigger for add. I will know, what's the next one? Difference. If I find a difference between two numbers, it's saying, what's the difference between 7 and 3? It's not saying literally, when people hear about difference, they think, okay, what are the things that make this one look like this and that one look like that, right? Like visually, you'd say, well, the 7 don't look like the 3. In terms of math and numbers, when we find a difference, it is referring to how bigger one number is than the other, or how smaller one number is than the other. So in this case, all I'm saying here, this difference is me saying that one of them is 4 larger than the other. 7 is 4 larger than 3. That's what difference mean with math. Difference don't mean this one blue and this one green. You get me? Or it don't mean that this one is a measure of which one's larger. That's all. All right? Product. Now, product is another trigger word or keyword. Product means that I am, if you notice, if we do add and subtract, yeah, what are the other operators we know? Multiply and divide. So then product is a keyword or a trigger word for multiply. So then now I'm finding the product. So that means I'm multiplying. How many things am I multiplying? Let me say 2, right? Consecutive numbers when the smaller one is y. So they have two consecutive numbers. Now the word consecutive, what does that mean, Jamaica? What does that mean, everybody? Yeah? When we say consecutive, it means one come after the other, right? So if consecutive, what I mean, like, give me two consecutive numbers. 1 and 2, 3 and 4, 5 and 6, 7 and 8. They're one after the other, yeah? So then now it's saying product is, we'll find the product, so that means we're going to multiply two numbers. So we'll say, all right, which two numbers we want to do? They say the smaller number is y. So then what's the next consecutive number after y? So if I give you a consecutive number after 7, then I would have 8. How am I create 8? 8 is the number before plus 1. So then now there's the same thing here. They want us to think about, this is a smaller number. How would I make the next consecutive number after y? It will be y plus 1. Yeah? So they're saying, I want you to multiply, because product is a trigger for multiply, right? Two consecutive numbers. And they say the smaller one is y. So then say y, yeah? And they want me to multiply it with the next the consecutive number after that, which is y plus 1. Yeah? Now, so that will give me, once again, we don't write multiplying of people. So we're just going to clamp it together in a bracket. Y bracket, let me put the bracket there, y plus 1. Yeah? And so that is the breakdown of those two marks right there. So we'd have 7x plus y here. We'd have y plus 1 here. Yeah? Right? And that is what they're looking for. Now, if they want me to go even further for this one, I don't know. I don't know how CXC kind of marks it, you know. You get me? But in my book, both of these two things are correct. Now, if they wanted me to take it one step further, let me make sure so everybody knows what to do here. Because it's going to help us with the next thing we're going to work on, which is some geometry with algebra. Now, what is this? This is 7. Let me kind of put it on a new page then. We have 7x plus y. And we have y plus 1. Yeah? Now, this object is multiplying with this object, right? So, if I gave you 7 and x, so what would that tell me? It would tell me that 7 is multiplying with x. So, 7 times x give me 7x. We learned about that earlier in the previous live stream, right? Now, what happens here now? When we're doing this now, am I only just going to multiply with the x only? So wait, that doesn't make no sense though. You get me? So how would he only multiply with the first one? You get me? It would only make sense if I have to balance it. Okay? You can't leave out the other guy, right? So then this 7 is multiplying with the first thing, and the 7 is also going to multiply with the second thing. Because everything in a math's about balance. So 7 times x gives me 7x. And then 7 times y, or plus 7 times y, would give me 7y. This is called expanding your brackets. Yeah? So what am I doing here? I'm using the object out here, and I'm multiplying it with everyone inside of the bracket. Yeah? That's all. Yeah? Pretty easy. So that could have been another version that CXC is looking out for as the answer. Just to make sure so everybody know. Yeah? Now, let's go here now. Now, this one kind of a little bit more involved. I think I'm going to save him. No, I can't save him because we're going to use it later. Alright, same thing now. This guy is multiplying with everything in there. So he's going to multiply with the first object, and he's going to multiply with the second object. So then y times y now. So wait, when we learn it before in creating expressions, we learn x times y, xy. Clamp them together. So if they're different, all we can do is clamp them together. Yeah? If I have p times q, pq. Right? If we have r times s, rs. If we have pr times x, prx. Yeah? So when they're different signs, different letters, we're just going to clamp them together. That symbolizes that they're multiplying. Now, there's something in math called exponents. I'm not going to give too much today, but I'm going to teach you one thing about them. Right? Now, y times y, if you notice, they're the same. Right? And so when they're the same now, we have to kind of treat it a little bit different than the way how when we treat it when it's different. So when it's y times x, clamp them together, move on. xy, right? Or yx, which don't really matter to me which one you put. The same thing. Yeah? When they're the same now, we have to make sure that we take a step back and make sure we understand. So y times y, that is when that thing about square and cube come out in people. Right? So this is called exponents. Now I'm going to give you the first exponent rule, right? And we can do the rest in another live, right? So by default, every number is raised to the 1 power. Yeah? So if I give you 5, he's really 5 to the 1. If I give you 10, he's 10 to the 1. If I give you x, he's really x to the 1. Once again, now, math people, we don't really write the 1, you know. That's the thing, though. Yeah? So, but you supposed to know, say it's there. Now, when we see this now, we say, okay, once this is the multiplication rule for exponents. Write it down. Make sure you write it down in the multiplication rule for exponents. I'm going to go rule 1. When the bases, these are the numbers down here, these are the bases. When they're the same, the base is going to come back and you're going to add the exponents them together. So that is how a y times a y give you a y squared now. Right? We're going to use it in the algebra for the geometry. So we're going to do some geometry today. It's kind of, everybody kind of flowing with it. So exponent rule number 1, multiplication. Once the bases are the same, add the exponents. Let's see if we can kind of do some real quick. Right? X times P. Yeah? Now, remember here, these are different. So when you're multiplying two different letters, you're just going to clump them. XP. Move on. Right? If I give you x squared times x cubed, the bases are actually the same. So when that's the case now, base come back, then what you're going to do with the exponents? Add them together and move on. Yeah? So that is the multiplication rule. So when they're different, what we do? We just clamp them together. When they're the same, exponent rules have to come out. Let's see if we can do a handful more and then finish up that question. Alright? So let's go to y cubed times y to the second. Go. Let's go. We're going to say go. We're going to go to 2p to the third times 4p to the seventh. Then we're going to go to 2x times 2x squared times 4y. Alright? Let's see if we can do that now. Right? So once again now, we have two buckets in the people. When they're multiplying these expressions, it's either going to be the same or going to be different. So we look at the base. The base looks the same. So then the base come back, you know, what we're supposed to do? Add the exponents. Yeah? So we're going to have y to the 5 here. So it's just like me saying, you have 3 of the y's them, and you have another 2 you're going to put on it, so you're going to have 5 of them now. Yeah, it's kind of like that. Yeah. Now, I convoluted it a little bit here, made it a little bit more complex, but we'll say, what did you learn from me last week? Right? Number times number, that's 2 times 4, 8. P cubed times p to the 7th. Do it in the sidebar if you need to. P cubed times p to the 7th. Are the bases the same? Yes, this is the base. Yeah, they're the same. Base come back. Add the exponents. Move on. Alright, so it's p to the 10th power now. Yeah? Right. Let's go again now. Number times number. We're going not number 3 now. Number times number, 8. Are the bases the same? We have a x squared times a y. This base don't look like this base, you know. So then what does that mean? Clump them together. X squared y. Yeah? And that is symbolizing that you're multiplying the expressions, right? So hopefully that helps everybody to kind of understand how to multiply with exponents. So let's go here now. We're right back. So we're expanding our brackets. So we said y times the first thing, y times this y gives me y squared. Yeah? Y times 1 will give me 1y. Yeah? I'm not going to write 1y now because 1y is the same thing as y. Once again, they don't like to write this one, everybody. But you know what, everybody? You can write it if it helps you. Trust me, you can write it. It's totally fine. Okay? Right? So I hope that makes sense. So we'll just finish up the 2 marks there, you know. But I give you a long explanation for both. Come on, make sure so everybody gets it. Yeah? Let's go to now. We created expressions in part B. Now let's work on evaluating. Now, something I see with students, listen, this don't have nothing to do with this, you know. Yeah? Don't. You always know when something has to do with something. So let's read this. It says, given A is -1, B is 2, and C is this. They want us to find the value of A plus B plus C. So then everybody, what my secret is, write back your guide. It said they want A plus B plus C. Then you know what you're going to do? This is your guide. So you know what? I'm gonna guide us to kind of get to the answer. Yeah? When you see this now, this is from a context of me don't know what A is, I don't know what B is, and I don't know what C is. So then now, when they're saying that given that this is this, now you know that A is this answer, now you know that B is this answer, now you know that C is this answer. So then now we can update our guide, because now we know that A is -1, so we change him out. That's called substituting, yeah? And then what you don't use, bring it back down. We don't use the plus sign, so bring it back down. B, change him out now, because we actually know what B is. He's 2. Then C, then we're gonna once again change him out, right? So then we're gonna put back our plus sign. We don't use him yet. And we're gonna put the -3 here, all right? So I hope that's making sense so far, yeah? Now, something you're going to learn from me if you come to any session with me, we never like when there's 2 signs between 2 numbers. Yeah? We have to make sure we figure out the sign. Is this number adding with the other number? Is this adding number subtracting with the other number? We need the clarity. So then now all we think about is positive times a negative gives you what? From last session you should remember it's a negative or a minus. So then this is -1 plus 2 minus 3. That's what that's going to be. All right. So then now let's calculate this. -1 plus 2. We're going to go 2 at a time. -1 plus 2. That is, I owe you $1 and I have 2. So then I can pay you off. I can give you $1 to pay you off. And I'm going to have $1 left over. So the answer to that would be 1. Bring back down what you don't use. So minus and 3. Right? 1 minus 3. You can use the calculator if you want, but we want mental work here. I don't want you to use the calculator too much. 1 minus 3. I have $1. I owe you $3. Do I have enough to pay you off? No, I don't. So then I'm going to still be... So then the answer to that one would be a -2. Yeah? All right? Let's go to the second one now. The second one says b squared minus c squared. So right now we're going to put down our guide. It says that they want us to evaluate this. And we're going to once again ask ourselves, do we know what B is? Do we know what C is? That's what you're going to then change it out with once you know that. So then we say to ourselves, yeah, we know what B is. B is 2. That says 2. So then we need to change out B to be 2. But remember, people, when you don't use, bring it back, no man, bring it back. So this is a square. So I bring it back. Yeah? Bring back now my minus sign. C is what? C is -3. So then I put -3 and then you put the brackets because you want to know that he's being squared. And then you put back your square. Yeah? So this is what we need to go calculate now. In the sidebar now, people, right? What we can do now? We can do the 2 squared. Right? Remember here, he's the base. He's the exponent. Yeah? The exponent, him just tell you how much time the base is going to appear. So 2 times. So I need to see 2 and 2. This is the base. I need to see him 2 times. Put it in with multiply, that's going to give me 4. So 2 squared evaluates to give me 4. Bring back down what you don't use. Please and thank you. -3 squared. Now some people would, let's kind of walk through this guy now. Once again, it goes back to the same rule of thumb. The exponent, he's telling you how much time the base will repeat. So this is the base. Make him repeat twice. 1, 2. Fill it in with multiply. Boom. Negative times a negative gives you a what, everybody? Positive. Check the last YouTube stream, right? All right. And then now 3 times 3 gives me 9. All right. Okay. Now, let's kind of address something that I see students kind of doing sometimes. So let's pull up the calculator and see if we can do some calculator work. So sometimes students, when they're putting in that -3 squared, yeah, them forget the brackets. Now, why is that important? Because if I put -3 squared, I'm going to get a different answer. I'm going to get -9. Yeah? So you have to ensure that you put the brackets so that the calculator knows exactly what you want him to do. So when I put the brackets now, it gives me the actual answer that I'm looking for, which is +9. Okay? Because 2 negatives, when they multiply, give you a positive. So this is now 4 minus 9, which would then give me -5, right? I have $4 in, but I owe you 9. I can't pay you off. So then I'm going to still be owing you 5, right? So that is how to get the 4 marks from this explanation, because I don't know. You guys tell me if you ever want me to speed up. Anyways, when I'm catering for everybody, I want everybody to understand what is going on. Alright? So 4 marks at an CXC, don't? Alright, let's keep on going now. Let's see now. Let's take a pause. Let me do a time check also. We're looking good on time. So then now let's go into some more things. Alright. Now we're gonna go into geometry a little bit. Now before we're going to the CXC level, because you think about it, these are the CXC level, right? We have to make sure we understand different levels that are below that. And so, like in what we have kind of designed on our platform, right, is supposed to help you with that, right? So if you notice, anytime I'm going to go in the platform, you're going to see that there's going to be different categories of things you can select, and there's going to be different levels, right? The exam level is the ultimate when you're going to be saying, okay, I'm ready for the CXC type of questions, right? We will first get used to the levels below that. You get me? And that is how you're going to kind of organize your learning, yeah? Now, this one now, what do I need to teach you? Well, I need to teach you some foundational things in terms of, we're going to talk about the perimeter today, yeah? So suppose we have a house, and this is our house. I'm going to make up a house. This is our house, people, yeah? Right? I'll put in some measurements also. I'm going to say that from here, 7 centimeters to here. From here, to here. Man, an artist, you know. Well, so see with me, man, an artist. Alright, where does that go? This is, give me a number, man, 11 centimeters, right? From here to here, he is 13. And from here to here, he is 12. Now, first thing I'm going to kind of address here, a lot of times for questions for CXC, they're going to say the word not drawn to scale. I'm going to take this chance to kind of see if I can talk about this guy. What I like to talk to students, I said, when you see not drawn to scale, it means don't trust your eyes. That's what it means to me. Don't trust your eyes. Now I'm going to give you an example of what I mean here now. It's like me saying that this side over here, he is 22 centimeters. Yeah? Now, if you trust your eyes, you'd be saying, well, sir, then I'm in a sense. From yes to yes, at 22. But always here to here, 13. That I'm in a sense, sir. Yeah, because it don't look like that. This side don't look longer than this side, don't? Right? And that's what not drawn to scale means. It means that I'm not drawing the diagram accurately for what the measurements are. So hence, don't trust your eyes. So if I was going to truly draw that shape, right, then it would have something look like this, with a 22 very long, and then this guy over here very short. Something like that is what is going to be expected. This is like what it would be if I said it was actually drawn to scale. Because the 22 look far longer than the 13, don't? Yeah? So what I want to make sure everybody understands here, when you see not drawn to scale on a diagram for CXC, it means don't trust your eyes. Trust the measurement. They're saying that there to there measures that, so you make sure you trust that. Okay? Now, let's go into now what's the perimeter. Now, this is the house, you know. So we want to build a fence around the house. We want to build a fence. So if I want to build a fence, obviously I'm going to place the fence around my house, right? So it can cut off from the next house or cut off from wherever, right? It creates an organized space, right? So then now to find the perimeter, some students learn add up all of the sides them, sir. That's cool. That's cool. I want to make sure I be a little bit more direct here. When I ask you for perimeter, listen, take my stick man on a journey, bro. Please and thank you. I need to go around the house. Walk me around the house. Now, why am I calling this out? It's because sometimes I can include other measurements in there. Like say, for example, this is 10 centimeters. And some students will include the 10 in there too. I'm going to say, wait. You know, I take the man on a journey around the house. This mean we're going through the house, you know. That's what this means, you know. We're going in the house. We want to go around the house. So if I want the perimeter for this shape, I'm going to say 22. That means that you took my stickman all the way to here, so cool. Continue with the journey, please. Then it's going to go down here. So that means that's 11. So cool. We're now going to go up on the 10 centimeter line. That is going through the house. I need to go around the house, people. Right? So then I'm going to go around it. So I go to 13. In fact, let me use some more of these. So we got 22 first. 11 next. 13, because we have to go around the house, people. Yeah, and then we're going to go lastly another 12. Yeah, so that's what I want to call out in this little quick little snippet here, that you understand that perimeter means take the man on a journey around the house, please. All right, what does this add up to? This is 25, and this is 33. 25 and 33 makes 58. 58 centimeters would have been my perimeter. Yeah, now let's see if we can apply it now. That's all I needed to do for that one. Just make sure you understand what perimeter is. Okay? Now the diagram shows a quadrilateral with the length of its sides written in terms of x. So then give us expressions. Now remember here, the expressions are just a placeholder. It's supposed to evaluate to give you a number, so you actually know how long it is, So we're going to first use the expressions though. So it's a write an expression in x for the perimeter of the quadrilateral. Now pause. What is the quadrilateral? What is this word? Go chat GPT, YouTube it, whatever. What is a quadrilateral? Please and thank you. Yeah. Who is a quadrilateral? Yeah. So quadrilateral, if you ever been on a quad means what in English? 4. So what could they be pointing out? That this shape has 4 different sides. So a quadrilateral is a 4-sided figure. So when I ask you what's a 4-sided figure, don't tell me rectangle, please. That's a type of quadrilateral. When I tell you what's a 4-sided figure, don't tell me square. That's a type of quadrilateral. Yeah? So the square, the rhombus, the parallelogram, the trapezoid, what else do you learn when you know square, rectangle, rhombus, parallelogram, trapezoid? Those are the 5 that they love to test, right? Those are the 5 types of quadrilateral. Now these are not any one of those, This is a 4-sided figure. He's not the square, rectangle, whatever, trapezoid, rhombus, parallelogram. He's not one of those. But the whole point is, any 4-sided figure is called a quadrilateral. Yeah? Alright, cool. Boom! Express the answer in the simplest form. 2 marks, we need it. Yeah, every mark's needed. Now it says the perimeter, people. So write it down. Perimeter. Yeah? Now, what did I say? Did I erase it? No, I didn't erase it. Right? What did I say about perimeter? Take the stick man on a journey, please. So we're going to take him on a journey. It don't matter where you start. So you can put your stick man anywhere. Right? Where would I go in order to get around the shape? I'm going to have to first go here. How much would I have to travel there? 15 minus 2x. So write it down. We're going to formulate the big equation and the expression, and then I will move on. So now he's here, people. So then now where am I go next? Am I going to go down here? Because I'm going to go around the shape. It's like I put in a fence. So then I'm going to add, what's the distance? The distance, if we give you 7 centimeters here, you're going to give me 7, don't? So we're giving anything in front of the centimeters is what you're going to put back. 3x minus 7. Yeah? Then he needs to go across. And that's going to give me 2x plus 5. Then he needs to go where again now to get around the shape? All the way back to the original spot. So plus 2x minus 1. Make sure you understand that this is the just distances. But we have written it as an expression. Yeah? Because that is what CXC asked me for. Write an expression in terms of x. Right? Now, let's see if we can... Now, this would probably give you 1 mark in my opinion. I don't grade for the CXC exam, so I'm not saying that that's what you would get. Right? But now they said, specifically, I need my answer in the lowest form. So that means that you need to take this down a little bit more. So let's talk about the simplifying process now. When you're going to simplify expressions, right, look for who is similar. Because if I give you 2x and I say add 3x, you're going to combine these 2 objects to get 1. I have 2 phones plus 3 phones. That's going to give me 5 phones. 5 of the x's. 2x plus 3x will give me 5x's. Yeah? So if you notice, I've shrunk from having two things separated to having one thing that represents them both. So the same thing they want to do here. What looks similar? So we'll first start off with the numbers, because I'm starting with numbers here. 15. Are there any more numbers in this whole entire expression? We need to move them so he can combine with this 15. So we'll look and we'll say, no, he's not a number, he's not a number, he's a number. So then now what my students learn? We grab the sign and the object and you move him. It's like a record coming and taking it up and moving him. Yeah? Then I will say another number here, sign in front and the number and move him. Yeah? Sign in front and the number and move him. So now all I number them together. So they're going to combine to give you one number. Just watch. Right? But then now remember, we had letters in there. So then we're going to move back the letter. So this is 9 is 2x. So we'll put it back. Right? In fact, let me put all of this in a blue. So the numbers look like, all blue. And the letters will look all red. So put him back. But remember here, if ask yourself, do I see any more x's in here? Yeah, man. Sign on the number, sign on the object, moving. Sign on the object, moving. You notice that no sign and no object get left behind? Everybody found a way down. Yeah? All the reds are going to combine because they're all x's. So they can all be combined in one go. All the numbers can be combined in one go. So they know 15 minus 7. Don't use a calculator. Using the brain, please. Don't use a calculator. Alright, this is 8. 8 plus 5, give me what? 13. 13 minus 1 gives me 12. Yeah? Then now, negative 2 plus 3x. I owe you 2 and I have 3. So how much would I have now? One of them. Yeah? 1 plus 2 gives me 3. 3 plus 2 gives me 5. So I'm going to have a positive 5x here. Alright? Let me audit myself and make sure I never make a little mistake. But it look good to me. Yeah? So remember here, perimeter, take my stick man on a journey around the shape, please. Right? It don't just mean other part of the sides. Yeah? It means I need to go around the shape. Right? So then now we get the perimeter. This is 2 marks now. Yeah? So 2 marks is that we've said, CXC said they want it in the simplest form, and I'm giving them in the simplest form. So perimeter equals to 12 plus 5x. Alright? And you're confident. You feel good. That's the whole point. Yeah? Now, they say the perimeter of the quadrilateral is 32. Okay. Is there something I can update with this? Because if you notice, I put a little guide here, So everything you're going to learn from me when you come to my classes or when you see me on these platforms, you're going to notice that math is all about equations. When you have an equation, it's a guide. So a perimeter equals to 12 plus 5x. Do I now have any new information? Yes, you told me the perimeter is 32 because now we're in part 2 now, right? It says find the length of the longest side of the quadrilateral. Yeah? So then now we're going to say, well, I created a guide from part 1. The perimeter, I can't spell apparently. Perimeter is equal to 12 plus 5x. Yeah? So then now they said the perimeter of the quadrilateral is 32. What can you update with this? Anyway, you see perimeter, you can change him now with 32 because they said that the perimeter is 32. All right? Okay, so that is what I wanted to make sure that you guys understand. We are always going to be creating some sort of guide. It helps you. So it helps you say, you can't say, I never know what to do, I lost. Right? You always want to say, what equation can I create? Yeah? Now, to solve equations now, let's go into another page. So we have 32 equals to 12 plus, what was it, 5x? Yeah, 5x, yeah? Now, this is now testing everybody's, can you solve an equation? So, what we were talking about before, to get this, that was simplifying expressions. We're combining them. Now, when it's talk about solving equations now, my students go through a little bit of a process here. So let's see if I can make it in a quick way for you guys, right? Now, every object in an equation must be doing one of the 4 things: adding, subtracting, multiplying, or dividing. Must. Yeah? So then I ask you the question, what's this 12 doing? He's adding with the 5x. What's this 5 doing? He's multiplying with the x. Because that's the only way you get 5x, of 5 times x, don't? So if I ask you, what's the 5 doing? He's multiplying with the x. Hope that makes sense. What's the x doing? He's multiplying with the 5. So everything when I ask you a question is for a reason. Everything in the equation must be doing one of those 4 things. All right? Now to solve for something, right? Suppose I'm solving for x, right? Main thing I want everybody to understand is this is called the left-hand side of the equation. Yeah, left-hand side. This is called the right-hand side of the equation. Yeah? To solve it, you remember when you solve it, normally you get x equal to something nice like 5 or an x equal 4. So to solve it means that you're isolating. You don't want x, you don't want nothing with the x. You just want x by himself. So then you ask yourself, where is he? X is on the right-hand side. So then all you're going to focus on is on the right-hand side. What things do you need to remove so that you reach to the goal of having him by himself? So that would have mean, say, Spidey senses say, I need to find a way to get rid of him. I need to find a way to get rid of him. Yeah? That's what that would mean, right? And then step by step, you're going to get rid of each one of them. So we're going to learn how to solve equations here. Yeah? Now, some students learn, move this over there and move this over there. Well, we want to make sure you understand why you're moving it over there. All right? So the goal was to get x by himself. So then we're going to first move the 12. I'll give you the reasons of why later. What's the 12 doing? What action is he doing? Is he adding? Is he subtracting? Is he multiplying? Is he dividing? Which one is he doing? So if you told me he's adding, cool. Then we can move on. If you don't get that, let me know in the chat. So then to remove him, I have to do the opposite of what he's doing. What's the opposite of adding? That's how I'm going to get rid of him. I'm going to subtract him. So I'm going to subtract him here. Him gone now. Because that was the mission. I have to remove him. So he can't be on the right-hand side no more. But then he does a miraculous thing here where he pops up on the left-hand side. Yeah? Now, that's because in math, we have to balance everything. What you do to the right side, you have to do to the left side. What you do to the left side, you have to do to the right side. Yeah? So then now we find what's the updated equation here. 32 minus 12 gives me 20. Bring back down what I don't use, equal. This gone, So I'm not supposed to ever see him again. Then I bring back down my 5x. Yeah? Okay? Now remember, the goal is to get x by himself. Right? So then we'll ask ourselves the same thing again. Where's the x? He's on the right hand side. What do I have to remove so he's by himself? The 5 now is what I got to remove. What is the 5 doing? He's multiplying, yeah? That's the only way you can get 5x. Well, one of the ways, right? How do I remove him? You do the opposite. So we're going to do the opposite to remove him. So if you multiply him, I'm going to divide him now. So I'm going to divide him by 5. Remember, people, the goal of this step is to get rid of him. So there's no way you're supposed to see him again. There's nothing that you are supposed to be calculating. That's why I tell my students, listen, don't just cross him out, please. Him don't exist no more. Alright? What you do to that right hand side now, you make sure you do it to the left hand side. What's my updated equation? 20 is being divided by 5. That give me 4 is equal to x. And that is us solving for x. Yeah? So then now, that was x. So we got that x is equal to 4. Now it said he wants the length of the longest side. So then now, remember what I said to you before. These expressions were just placeholders. That's all they were. So when we find x now, we can actually go find what was this actual measurement here. So now for each one of these, yeah, I want you guys to go and find out what is the value. How long was each one of these sides? Because now we know what x is, x is 4. So now we need to go plug it back in here and find out what are the different lengths. All right? So let's see if we can do that. So from here to here, let me kind of put it in a little color. For the green, it measured 15 minus 2x. So once again, you put your guide. 15 minus 2x. Now, do you know any new information? Yeah, x is 4. So then now we're going to put 15 minus 2. Change out the x with 4 now. And then let's see what we can do now. Right? Now I'm going to zoom in a little bit, because I see some students doing some things and I want to make sure, hopefully it's not going to be, hopefully it can help you, right? I see some students doing 15 minus 2 first and then do the 4 after. Wait, pause. Whole many pauses here, yeah? So this brings me back to I don't know if you guys, let me know if you guys learned BOMDAS. If you guys learned BOMDAS in class, let me know if that sounds familiar. Yeah? So what happens here is because I'm not writing the multiply sign, you're not realizing that these two are multiplying. Yeah? So right now, we have these two multiplying, right? So that's one operation. And we have the subtraction thing happening. Which one of these come first in a BOMDAS? This M stands for multiply, last I checked. This S stands for subtract, last I checked. Yeah? This A is for add. This D is for divide. All now, nobody can tell me what the O stands for. And B is for the brackets. So then now, you're going to realize that these two things are multiplying. So multiply needs to happen first. So I'm going to bring down the 15. Bring down the subtraction sign. 2 times 4 gives me 8. Then I can go to my subtraction after that. So that gives me 7. Alright? So then now, that green part, he measures 7 centimeters. So now you can start for like change them out now. So this is, it's not no expression no more. It's 7 centimeters, you can say confidently. Yeah? Then now let's go to another one now. We're going to go to 3x minus 7. Remember now, do we know any new information? Yes, x is 4. So then anywhere we see, once again, you put a guide, everybody. Put your guide. So then this is 3 is multiplied with x, right? So x is 4, so we'll change them out with 4. Bring back down what I don't use. Bring back down what I don't use. Once again, you apply your BOMDAS again, right? These two things are multiplying. That's one operation. And we clearly see the subtraction. Which one comes first in a BOMDAS? That's the one you're going to do first. So 3 times 4 gives me 12. That's multiply. Bring back down what you don't use. Bring back down what you don't use. 12 minus 7 is 5. So then we can change them out to be 5 centimeters now. Yeah? So you're basically finding out, because they want to know, which one is the longest side. So they want to know which of these is going to calculate to give you the longest. Yeah? So now, I'm doing a long version of it because I want to capitalize on you guys knowing how to evaluate expressions. Yeah? So then now we're going to say once again, do I know any new information? Yes, x is 4. So then now 2 times, you see how redundant it starts to become after a while now? Yeah? Ask yourself, what are the operations? Multiply. I see a add. Which one comes first in BOMDAS? Write it down for yourself if you need that guide. Yeah? You'd start to see that multiply comes before add as I look down. So then I do my multiply first. So that was going to give me 8. And then I'm going to add my 5. So then that's going to give me now 13. Yeah? So then this guy now, he's 13. Because we'll find x, x is 4. So we can find all of the lengths them now if we want to. Because we're trying to figure out which one is the longest side. Then the last one we're going to go to is 2x minus 1. This guy over here. Once again, you know x is 4. Anyway you see x, you can change him out now to 4. So this is 2 times 4 minus 1. Once again, two things come together is multiplying. And then we have the subtraction sign, redundancy. Which one comes first in BOMDAS? Multiply. That's 8 minus 1, which gives you 7. So this will be now 7 centimeters. Which one is the longest? Looks like this guy down here. So then that means that the longest side of the quadrilateral would have been 13 centimeters. That's what would be the longest side. And make sure it's going to write the actual thing that I'm asking for. Longest side equals 13. Yeah? And that's where you get your full marks. Yeah? 2 marks for it. I think the 1 mark for the x and then the other mark for longest side and finding what is the longest side. Yeah? So hopefully that makes sense. Put some questions in the chat. Don't forget to like and subscribe. And also to share, please. I need to share with all students, please. All 5th form students, all 4th form students, every student. Yeah? I want to get this out. I want to help everybody get better at math. Because it's not hard. It really isn't. Alright, coffee break. Let me know. Yeah, coffee break real quick. And then I think, let me do a time check. Oh, we're right at I'm going to do a wind down now. How about a wind down? Yeah? So the other question I had to do with area. Yeah? Area. And so we're going to do that. We can do that in the next week's live stream. Alright? Let's kind of do a wind down here. What did we learn today? Right? We learned how to create expressions. Let me kind of pretty it up a little bit. Hopefully. Yeah. So we learned how to create expressions. Creating them. I can't spell. Creating. There we go. Right? Evaluating expressions. Yeah. Boom. Then we learned how to apply it with the perimeter. What's the perimeter again? Please don't tell me add up the sides, sir. No, man. Take my stick, person upon a journey around the shape. That's what the perimeter means. All right? So that means that you're going to be taking him on the journey and adding up all the sides as you go around it. Yeah? Do not add anything that is inside of the shape. So if I give you another line here and I said that that was 10, he's not a part of the perimeter. He's not going around the shape. He is inside of the shape. I don't want to see him. I only want things on the outer edge of the shape that you're talking about. Okay? We learned how to solve equations also. So that came from the idea of understanding what objects are doing. So we evaluated, we created, we evaluated, we solved equations, and we created expressions. So these are the 4 pillars that kind of help you to navigate the harder things them. So the matrices, all of them are going to come to an equation. You get me? The trigonometry, all of them will come to an equation. You get me? So I want you guys to understand that that is why we want to start here. And make sure you guys feel comfortable there. Alright? So I'll check you guys in the next live stream next week, Saturday. Now that time I will have, what is that? Next week is bring your questions. So you have your chance to submit any questions you want me to kind of do on the platform. So obviously I have to kind of, select the ones that you guys choose. Like it's going to be too much. So I have to select the ones that are, easier. Not easier. The ones I have to, if you guys give me 10, I have to go only choose a few of those, right? But what I'm going to try and do is try and see how I can connect them together. Or in some way, shape, or form, or do multiple that has to do with the same theme in the same soup. All right? So bring your questions. That's what's going to happen next week. So I'll see you guys